Okay, good morning class. So today we're looking at graphs. So there's only one exercise in this section. It's a fairly long exercise. So I'm going to break the what's name up so such that we label it lesson 1, 2 and probably lesson 3 so that you don't have one long video. Also at the end of this I will be able to tell you exactly which questions in the exercise you should be able to answer this point. Okay. So we're looking at graphs, coordinate plane. Last year we dealt with coordinate planes. Okay, so this is a refresher. To represent x is equal to 2, we use a number line. Okay, that's all. So if x is equal to 2, I can just put the dot there. That means to say x is 2. That's all, on the axis variable. But to represent y is equal to x plus 2, we need an x-axis and a y-axis. Okay, so what they did was they took a number line. Okay, there's 1, 2, 3, 4. So they got the 0, 1, 2, minus 1, minus 2. And they took exactly that number line and they turned it 90 degrees and put it on the 0. So that is 0 again. 1, 2, minus 1, minus 2. And so on. Okay, so together, if I ask you to plot the point A, which is 1 and 2, I go with x is 1 and y is 2. Can you see here? That's going to be that point. A, 1 and 2. Of course, that goes all the way to infinity and negative infinity and so on. Okay. I ask you to plot the point C, which is 0 and negative 2. So the x is 0 here and y is negative 2 there. So that is going to be your point C and so on and so on. Okay. But to represent that, we need x and y axis. This coordinate plane is called the Cartesian plane. Okay, so that's a beautiful Cartesian plane there. Remember, it's your x and the y. Coordinate form, always write x and y. So O is the origin. O is the origin with coordinates 0 and 0. Okay. As you can see there, O is the origin, which is 0 and 0. A, which is 2 and 4. So x is 2, y is 4. Is an ordered number pair, or ordered pairs. Okay. Remember, we always write x then y. Alright. So here we got couple of coordinates here. So we got A, which is 2 and 4, and B, which is negative 1. X is negative 1, y is negative 2. Okay. Next question. It says write down the coordinates of A to E. Write down the coordinates of A to E. I think we are on the next page. On page 64 now. Alright, so let's look at A. So A corresponds with an x value of 4. So A is going to be 4 and a y value of 2. Let's look at B. There's an x value of negative 2 and a y value of, let's look at C. There's an x value of 0, x value of 2, as you can see it's on your x-axis, and the y value of 0. Let's look at D. Got the x value of, what's your x value? 0. You got the y value of negative 2. Let's look at E. We have an x value of negative 4 and a y value of 1. Remember that is y and that's your x. No? Negative 4 and 1. Then F. No. So any confusion at this point? No. Remember that this will always be called O for origin. And what's the coordinates of the origin? 0 and 0. Okay. Note that every point on the x-axis, example -4 and 0, -1 and 0, 1 and 0, 2 and 0, has a y coordinate of 0. So what they are indicating here, if I take this into account, this would simply be 1 and 0. We know that was 2 and 0. That is 3 and 0, 4 and 0, 5 and 0. Can you see that? This here is -1 and 0. -2 and 0, -3 and 0, -4 and 0. What do you notice? Anywhere on your x-axis, y is 0. Can you see that? Likewise, if you go down this way, that is going to give you 0 and 5, 0 and 4, 0 and 3, 0 and 2, 0 and 1. 0 and 0, 0 and -1, 0 and -2, 0 and -3, 0 and -4. So what do you notice anywhere on your y-axis? X is 0. Anywhere on your x-axis? Y is 0. Okay. That's why when we worked out our dual intercept method, what do we say? Your x-axis, let y equal to 0. And for your y-axis, let x equal to, and this is the reason why. Okay. So here we say note every point on the x-axis has a y coordinate of 0. Similarly, every point on the y-axis has an x coordinate of 0. The graph of y equals to mx plus c using a table. So you're given that y is equal to x plus 2. To draw a graph, choosing a few x values and calculate the corresponding y values. Do this using a table. Now, at this point, you guys have been exposed to these graphs already, to drawing the graphs, so this is just a refresher. So, we are given -3, -2, 0, 1, 2 and 4. The question says, draw the graph using the table. So what we need to calculate the corresponding y values. Not so. So I put -3 into x here. What do I get? -3 plus 2. What's -3 plus 2? -1. So -1 goes there. What's -2 plus 2? 0. 0 and 2. 1 and 3. 2 and 4. 4 and you all agree with that? So now the question says the values in the table can be written as coordinates, or also known as ordered pairs. Okay. If I look at the first point, -3 and -1 would be your one coordinate, followed by -2 and 0. Followed by 0 and 2, followed by 1 and 3, followed by 2 and 4, followed by 4 and 6. Okay, I forgot to take this line out here, but anyway, if x is -3, then y is -1. Then you plot this point here. X is -2, y is 0, which is that point there. X is 0, y is 2. X is 1, y was 3. X is 4, y was 6. And x is 2, y was 4. Okay, and then what we do is take a ruler and we rule a line through that. Okay. If these spaces was measured out, if it was drawn to scale, then your straight line should go through all of these points. Okay, that's why when we started this off, I gave you a grid page, no? So that you can plot the points in the grid and you'll see that that will be the case. Okay. But what is the minimum amount of dots you need to draw a straight line? 2. Okay. So from here we derive that the graph of a linear function, namely y is equal to mx plus c, is a straight line. People, linear also means straight line. Yeah? So linear means 1. Alright. So the standard form is y is equal to mx plus c, where m is your gradient, slope or inclination. Okay? Inclination angles, and the incline of the graph is also your gradient. Okay? In grade 11 we talk about, we calculate the inclination angle, or the angle that the linear graph makes with the x-axis. C is your y-intercept, i.e., or in other words, where the line cuts the y-axis. Okay. Here we'll see that if the gradient is positive, greater than 0 means positive, no? When the gradient is positive, then this is what your line is going to look like. It's going to lie to the right. We also see when the lines lie to the right, this graph is increasing. So as x moves from left to right, as x gets bigger, the graph gets bigger, increasing. If x is less than 0, the graph is decreasing. Okay? Or the graph will lie to the left. If the gradient is equal to 0, it will be a horizontal line. The line will be parallel to your x-axis. Okay? If your gradient is undefined, then your graph will look like that. Okay? But we'll speak about that again in later calculations. Okay? To calculate m, what is m? Your gradient. How do you calculate the gradient? Delta y over delta x, so it's changing y over changing x. What do we calculate it as? y2 minus y1 over x2 minus x1. Or y1 minus y2 over x1 minus x2. If you got y1 first, x1 must be first. Or ya minus yb over xa minus xb. And so on and so on. There's an infinite, different amount of ways you could have written that. Okay? Likewise, you could have said y10 minus y2 over x10 minus x2. Okay, and so on and so on. yp minus ya over xp minus xa. And so on and so on. Okay. So the instruction is now to write down the gradient m and the y-intercept of c. Or the y value. The y-intercept, yeah? Or your c value. So if you look here, what is your gradient here? Gradient is? Remember the equation is y is equal to mx plus c. So what's your gradient here? 3. And what's your c value? So you say your y-intercept is negative. What's your gradient here? 4. And your y-intercept? 1. What's your gradient here? 3 over 4. And what's your y value? What's your gradient here? Negative 1. What's your c value? Negative. Remember that the sign is part of the term. Okay. Okay, number 6. No, number 5. So gradient here. 1 over 3 is. And the y value of the y-intercept of 1. What's your gradient here? Can we draw the gradient at this point? No, it must be in standard form. So how do we get this in standard form? It must be in the form of y equals mx plus c. So y must stand on its own and everything else on the other side. So of course we're going to take the x over, so 2y is equal to minus x plus 4. So how do we get y on its own? Divided by 2. Right. That cancels. So y is equal to negative half x plus 2. So what's the gradient here? Negative half. What's your c value? Okay. Or your y-intercept is 2. Look at the next one. So again it must be in the form of y equals mx plus c. Not so. Take it over the equal sign, so it's negative a third. Negative a third y is equal to minus 2x plus 1. So how do I get rid of negative a third? Multiply it throughout by negative 3. Or you can divide everything by negative a third. The same thing, okay? So y is equal to negative 2 times negative 2x times negative 3 is positive 6x minus 50. So what's your gradient here? The gradient on this graph is 6 and it has a y-intercept at negative 50. Okay. People see any confusion? No. Okay. Then we are told here the graph of y is equal to mx plus c using the intercept method. Okay. And this is the method we are applying all the time. Not so? So we said for the method, you work out your y-intercept. How do you work out y-intercept? We let x equal to 0, then you owe it your c value. Number 2, your x-intercept with y equal to 0. And thirdly, plot the 2 points and draw the graph. That's what we're doing all the time. Okay? Looking at this for the first time, this would be your notes you'll be making on this one. The full lesson can also be found in the description box. We will in example 1, you are asked to draw the graph using the dual intercept method. Okay, so where do we start? We say y-intercept, what do you do for y-intercept? Let x equal to 0. So we have y is equal to negative 2 times 0 plus 4. What's negative 2 times 0? 0 plus 4 is 4. Or I could have just seen there that the y-intercept is 4. Okay. Then we work out our x-intercept. What do you do for x-intercept? Y equal to 0. So 0 is equal to negative 2x plus. Take that over the equal sign. So 2x is equal to 4. So x works out to be. So this is enough information to draw the graph. Okay. So let's go. So y and this is your. So y is 4. It's approximately there. And remember that is 0. Okay, and x is 2. Now it's not going to be the same length as this. It's going to be half that length. So it's just again by approximation you write it 2. You don't have to go 1, 2, 3, 4, 1 and so on. You don't have to do that. Okay, just by approximation. If it's more than one graph on the system of axis, then you'll see me writing that there. Those strokes. To give me a better gauge of the graph. Okay, but if you're that kind of girl that needs to write it down, no problem. Okay. And there's our graph. Any confusion there, people? So we said this graph is increasing or decreasing? Decreasing. We could have seen that the gradient is negative, which would also result in the graph being decreasing function. Okay? And here we can also see if we, more or less, if we are on the right track. Okay? Because if the graph is increasing with a negative gradient, of course we made a mistake somewhere. Okay? So the next question, number 2. We are now on page 65. 66. Okay. Example 2. We are asked to sketch the graph or draw the graph y is equal to half x minus 3. So where do we start? We start off with our x-intercept. What do you do for x-intercept? Put y equal to 0. So 0 is equal to a half x minus 3. Take minus 3 over the equal sign becomes positive 3. Divided by a half both sides. It cancels, so therefore x is equal to 6. You say 3 divided by a half. Do you? So what do we do now? Y-intercept. What do you do for y-intercept? You did? X equal to 0. Is that in standard form? Yes. So therefore y is equal to negative 3. Which is this value here? Your C value. Okay? So what do we do now? There's enough information to draw a graph. As we said, we just need 2 lines to draw the graph. Is this an increasing or decreasing function? It's increasing. Not so. So x equal to 6 and y is equal to negative 3, which is half of that there. Okay. You all understand? So we draw the graph going through that point there. And of course this point here. Okay. There we go. Make sure that's going through this point. If you miss it, you just make a dot there to indicate you know it's going through. Okay? You all understand? Let's go to the next page. Now the next question. So now we have 2 graphs here. The question says, draw so yeah, I will do that marking sign because there is 2 graphs on one system axis. So it says draw y is equal to 4x plus 1. So let's go with the first one. What do we do here? Y-intercept. What do you do for y-intercept? Let x equal to 0. So y is equal to 1, which is also that value. X-intercept. What do you do for x-intercept? Let y equal to 0. 0 is equal to 4x plus 1. Get over the equal sign divided by negative 4. So x is negative a quarter. Okay? If we draw that graph, y and x. So y is 1. Okay. So we will draw this graph. Y is 1 and x is negative a quarter. So if this is negative 1, it's negative half, negative a quarter is there. You all agree with that? I don't know why they use the what's name values here, so small values. To highlight the effect here, but I would have used bigger values. Okay. Okay, that's the one graph. And this is the y is equal to 4x plus 1. Also note that if we're drawing more than one graph on the system of axes, we always label the graphs as well. Okay. So here, your y-intercept, what do you do for y-intercept? We let x equal to 0. So y is equal to negative 2. Then we got x-intercept. What do you do for x-intercept? Let y equal to 0. 0 is equal to 4x minus 2. We get over the equal sign becomes minus 4x is equal to minus 2. So x is half. So x is half here. That's off, of course. That is one, that's off. And you have a y value of negative 2. Now, this graph is not drawn to scale. It's not exactly off all the way, né? But what effect do you see here? What do you notice? Huh? Can you see that this half here is smaller than that half? No? So let's move it in accordance. What do you notice? The lines are parallel. The lines are parallel. So, looking at the equations, what do I notice? If I look at the equations, we got y is equal to 4x plus 1 and y is equal to 4x minus 2. What do you notice? They're the same. M, which is your gradient. Can you see that? So if gradients are the same, what do we know? Lines will be parallel. So make that note there. M1, if M1 is equal to M2, which means to say the gradient of the first line is equal to the gradient of the second line. Then lines will be parallel. So if gradients are the same, lines will be parallel. Or if lines are parallel, gradients are the same. And we're going to use this extensively all the way to matric. Okay. Lines are parallel, gradients are equal. Alright. If M1 is equal to M2, or the first gradient is equal to the second gradient, then the lines will be parallel. Okay. And here's a note. Okay, they made a note as well. If lines are parallel, the lines are parallel because the gradient is equal to 4. As mentioned before, M is the gradient slope or inclination. M is the same, lines are parallel. Okay. So now we're going to look at the graph of y is equal to a and x equal to b. The question says you're on page 67 now. Y is equal to a and x equal to b. So y is equal to 3, and I draw here saying that is 1, 2, 3. I draw this line going through like that. Okay, so that is the y is equal to 3 line. You'll notice that it's parallel to your x-axis. Can you see that, people? So if I take this point on the graph, what would this be? 1 and 3. What would this point be? 2 and 3. What would that point be? 3 and 3. What would the point of 100 be? 103. What would minus 2 be? Minus 2 and 3. So what do you notice? Anywhere on this graph, on this line, y will be 2. You guys understand? But if the equation says draw the graph, what I just do is I do that. Y, x. I don't put all the points on there. I just draw the line there and name that y is equal to 2. Okay? Understand? If you want, you can put it as parallel to the x-axis. But you don't need to. Okay? Let's go on the other side. The next question. Note that in the example above, every point on the line has a y coordinate of Let's go here. So what do I do here? X equal to minus 2. And 2, x is minus 2. And that is minus 2 there. It will be parallel to your y. You guys understand? So you have to choose this point here. Let's go with 1 there. What would this point be? Negative 2 and 1. Then we'll go here. 2. And this point would be negative 2 and 2. We'll go there 5. This would be negative 2 and 5. We'll go minus 4 here. This would be negative 2 and minus 4. What do we notice here, people? Anyway, on this line, it has a constant value of x to be minus 2. Can you see that? So again, if they ask you to draw this graph, you just simply do this. It's your y and this is your x. It's your origin. That's minus 2. Your ruler line going through there with your ruler. You can say it's parallel to your axis. We don't even have to say that. You guys understand? Simple, no? Okay, note that in the example above, every point on the line has an x coordinate of negative 2. So let's look at the graph of ax plus by equals c using the intercept method as in number, as in 4. Alright, so do we have to put this in standard form? The answer, of course, is no. The question was not to calculate the gradient and the y-intercept. That wasn't the question. So to draw this graph using the intercept method, what do I say? Y-intercept. What do you do for y-intercept? Let x equal to 0. So you have 3 times 0 plus 2y equals negative 6. What is 0 times 3? 0. So I got 2y is equal to negative 6. How do I get y on its own? Divide by 2 both sides. Okay. So therefore, y is equal to negative. Now we go x-intercept. What do you do for x-intercept? Get y equal to 0. So you have 3x plus 2 times 0 equals negative 6. So that's gone. So 3x is equal to negative 6 divided by 3. So therefore x is equal to negative 2. And with that we have enough information to draw this graph. With y, x is negative 2, y is negative 2. And again, with our ruler, draw the line going through. Okay. But is there any confusion at this point? Not yet. Okay. Alright, so the next part is finding the equation. So that we'll do in a separate video, okay? I'll stop the video this way. So with that you should be able to answer out of the exercise is number 1, which you guys haven't done yet, so you'll answer number 1. The remaining part of number 2. Okay? So that should be able to answer everything up until there.